Hi everybody, Luke Gallant here from the YT624EJ maintenance channel. So I've actually got a water leak in the house and I've got to do some plumbing on an emergency basis. So I do have something to tend to, but I thought I'd first tend to this snowblower video. Why? I guess I'm crazy. These skids, I've started selling them on lgworks.ca and obviously we know what they're for. We don't need an explanation about this. One of the things I want to make sure is that I don't sell skids to people that break. I want to sell skids that last. I've already talked about why I don't use the Yamaha ones. Actually, I've got a couple Yamaha ones here, and the ones I have, the injection was actually decent. Anyway, in the spirit of making our own, I'm just gonna leave the Yamaha ones out of this discussion. So essentially, for 3D printing, there's many materials available in the market, and some are better, some are worse for making skids. So I'm not gonna get into the details of it. On my site, I posted polycarbonate, because polycarbonate is very cold weather resistant. But everybody kind of knows that polycarbonate isn't the most impact withstanding because it's a little more brittle. But because the impacts on this are they're rubbing and they're not, like the energy's not as high, I thought I'd go with it for a while. And for me, they've actually worked really well. But now that I've had maybe 10 hours of use, I do see a tiny little hairline crack in this section. So of course, the pursuit is to get the best possible skids from 3D printing. Why? Well, the cost is lower. And two, you can obviously make one whenever you need, etc., etc. So what I've done is on my desk here, I'll put it on the screen. I've got a list of materials that I want to stress test today. Much like this entire channel, Badger 2.0, a guy down the street here, that's his call sign. He got me onto this idea, and of course I couldn't let it go. So I intend to put ideas in his head too that he can't let go of and, you know, delay his critical house renovations. The water in my house is actually off right now because there's a leak in the basement, but I'm here because, you know. So I guess first and foremost, the reason I'm rushing to do this is because it's minus 34 degrees outside today without the wind. It's minus 42, 44 with the wind chill. Of course, wind chill does not apply to this kind of a test that I'm planning on doing. So at minus 34, I want to capitalize. My freezer is only at minus 16, so minus 16 doesn't give us, you know, good test. Minus 34 is better. So I'm going to run through the materials here with a little blurb about each. I'm going to use this sample skid just to talk about it with my hands. But meanwhile, all the skids in question that we're going to test, they're outside and they've been outside all night. So we've got PLA. PLA we would never use for this kind of application. It's much too fragile. It's got different purposes and typically prototyping. So PLA, we're not even talking about it. I'm not going to waste PLA just to show that it's not good. Like this has been done a bazillion times on the internet. PETG, kind of a step above PLA, and it's actually pretty durable in lots of cases. And so I'd like to test those in some of our stress tests. It's not typically viewed as the most robust material, so I kind of hesitated to sell PETG because, you know, I don't want to sell it to somebody then it breaks 3 days later. Then it's kind of, yeah. We got PC, which is polycarbonate. So polycarbonate's what I've been making mine with here and there, and we're going to test the sample here. Nylon, you know, is known and kind of loved by everybody. The issue with nylon is there's a couple kinds of nylons. There's PA6, there's PA12. PA12 is the type we would have to use because of moisture absorption reasons. But the issue is 3D printing nylon is very hard because it warps. And the ones I tried to print, which I did send out to some viewers, the slot here, you know, was so warped that I couldn't get the sleeve inside of it. So obviously when a person buys these, they want to be able to slide it onto the sleeve properly without any, you know, like even this one's pretty tight, but the nylon one, I could not get it on. I had to sit here and drill it and ream it, and like I don't want to send that to people, right? So, but nylon's very tough. So TPU is a kind of polyurethane, and TPU is extremely strong, and the layer line is extremely strong. The issue with TPU typically is that it's too soft and too flexible. But Badger 2.0 found some 72D hardness stuff on Amazon for a good price. And so I've got some TPU samples to test, and I think that may be our winner. I don't want to lead anybody here. The other one we've got that I really considered, but it's way too expensive, PAHT-CF. So it's common for nylon now to have carbon fiber, glass fiber reinforcement within it for 3D printing. And this is a high temperature nylon. The issue with this, it's about 4 times more than the TPU. So yeah, it's easy to make a set of 1 skids for yourself just as a one-off, but you can't start selling this kind of stuff, right? And as well, like, you know, with the carbon fiber reinforcement, the surface finish is kind of rough. So it smooths out, as you can see here, but this one's been put to the side. This one here was a super low infill one, so it's actually not very dense at all. If you hit it, it's not dense. So one of the things here is for these skids, I'm printing them solid. So what you could be doing here is putting infill where it's kind of hollow in the middle or partially hollow. But as the skid wears, that's going to, you know, as soon as you reach the infill, you're going to start destroying your skid. So people typically don't print 3D printed things solid because number one, it uses a lot of plastic. And number two, not that the printer can't do it, but it's very abnormal to just print solid chunks of plastic, right? But for these skids, that's what I'm doing. And you'll notice they're printing vertically to have the best stress distribution, because if you print them flat or on their side, you end up with the layer lines being at the interface points here. So when you print them vertical, you can end up with some support markers on there, so it doesn't look perfect. Whereas you print it on the side, it can look perfect, or on upside down, it can look perfect, this kind of a thing. But the issue is where the layer lines are and how. So if you're on this edge here or this edge, you know, you might have breakage that's easier, right? So one of the skids that Badger 2.0 printed out of polyurethane, there's one of each. So finally, how are we gonna do the stress test? Well, I don't want to be in here all day, and if you look on YouTube, lots of people, they spend lots and lots and lots of time stress testing 3D printed stuff, and obviously people love that, but so I want to try to kind of push through it a bit faster. So I'm going to go for a two-stage approach where I'll do a simple stage one, and hopefully it'll eliminate a few products, and then I'm going to move on to stage two, which is going to be a little bit more destructive. So stage one is going to be simple. I'm going to put a camera on the floor, high-speed camera. I'm going to start with the materials. I'm going to just drop them about 5-6 feet, same height every time, and we'll drop them onto this tile floor. And my high-speed camera is going to catch the impact point, and I'm going to do this, let's say, 10 times per skid. And I'm also going to stick this insert that I made inside the skid, you know, for fairness. Ooh, this insert pretty tight on this guy. That's a problem. So I'm going to stick the insert in there, and I'm just going to drop it over and over and over. And after 10 drops, you know, we shouldn't have any shattering of any kind, right? Oh, great, now that's stuck. Oh, that's a problem. All right, after the drop tests, whatever's remaining, we're going to stick them in the vise, and I'm going to do some calibrated hits in certain configurations, trying to be consistent. We're just going to do the same to everything, and we'll see what gets weeded out, and hopefully this allows us to make a choice as to what we want to run with here. The other option I thought of doing is letting the user decide what material they want and putting this whole choice on them, but that might lead to a lot of emails of people asking me, what should I choose? It might lead to confusion and people not being able to choose, so not buying them and what have you. If you want a special material, you can send me a note. Obviously the price might be a bit different, but I'd like to reach a point where it's easy to make that decision. All right, here we go. Drop test starting. We'll go PETG, PC, nylon, TPU, and I'm gonna write that in the bottom of the screen here so that you know what's happening, and we're gonna skim right through it real quick. Thanks. All right, so what did 40 gigabytes of high-speed data give us? So PETG, as expected, wouldn't be a good contender, and you'll see here why not. So PETG has the tendency to spall like this. So it kind of, because it was cold and because it got all that impact, it kind of spalls off and it chips off, which is kind of what we thought would happen. You know, you could see here the outer layer started peeling off. I think PETG could actually work for a while in a wearing application, but over time you end up with this kind of chipping and chunking. So PETG is a loser in this. Polycarbonate, the website favorite for a bit. So the wearing aspect of polycarbonate is really good, but you can see that under the impact, we start cracking down the middle here. You know, there's a tiny bit of chipping here from the impacts. So polycarbonate would be not preferred, even though I think it'll work for a really long time. So this was the TPU version with the layer lines printed like this, as I had mentioned before. And here you can see we have separation. So we broke across the layer lines, which is kind of a typical 3D printing failure mode. The other TPU version has no signs of any damage at all. So I think that's kind of what we expected. So we cross off PLA, PETG, polycarbonate, and the other one is like printing gold, the PHT, so we're not gonna do that. We're left with two choices. We got nylon or TPU. Nylon is about twice the price of TPU, and nylon is prone to loads and loads of warping. But in the interest of science, what we're gonna do is we're gonna put nylon and TPU to the test in the vise with a hammer and maybe some different leverage for strength test. And we're gonna keep the foot on the gas because this water pipe problem is not getting any better in there. All right, we're gonna try some calibrated hits here with a hammer from a couple different angles and just see how it goes. I've got it mounted up to the OEM skid holder, and I've got the slow-mo camera rolling as well. So here we go. So the polycarbonate was already discounted anyway. I just wanted to see how these cracks propagated. So let's take this guy out, put a different one in. All right, here goes the PETG one just to see what happens to it. Okay, so we've got full failure of the PETG here. So the PETG, as we knew, wasn't gonna cut it. We see here a full corner crack. All right, here we go with the TPU that's printed in the vertical with the strongest layer lines. So I'm gonna do some hits here. Now I'm hitting these skids on the back side because it is the thinnest part of the skid, even though obviously it rides on the other side. So this way we can test the strength in a better way. Very, very, very strong stuff. Okay, so the nylon, I can't get the piece inside because of the dimensional issue I told you. I'm gonna put it in a vise and we're gonna crank on it. All right, this poor block of nylon's about to get it beat. Let's go. So it's in there in kind of an unfair way. Okay, I mean, I crushed it, so it's not a very good test because I kind of crushed it a little bit. But the dimensional instability of nylon is really, really tough. And by tough, I mean it's hard to work with. We're gonna put the TPU in there and try to destroy it. All right. All right, so we've got breakage eventually, but this has been subjected to lots and lots and lots more impact than the snowblower is going to subject it to. So to me, I think that TPU is the right choice for this. I think it's going to be extremely durable. It's extremely strong. So you can actually see here what it looks like when there's infill. So I kind of did an apples to cantaloupe comparison in a sense. But that there is when the infill is on. Whereas it would be solid if the infill was kind of blocked, so to speak. So obviously here you can see that as it starts wearing down, you're going to start getting into the infill region, which isn't ideal. So I may be doing variant tests to this to see what works best, but Yeah, happy shopping. All right, so let's close this topic off. We're gonna summarize here the materials and our choices. Let's go through our materials here and talk about them. So PETG kind of broke early on in the drop tests. PETG, it's known that it's not necessarily the best material for cold, and it tends to do this kind of spalling and stuff, so that would not be a good choice. PC actually performs really well. It's just that it's not very flexible, so it tends to crack. It's a little bit more brittle. So we saw a crack here, but otherwise it's a very, very, very strong print. And nylon is exceptionally strong, but it's really annoying to print, and dimensionally it gives a lot of issues, and it's 3 times the price. So polycarbonate is like $60 a roll, nylon's up in the $70 to $80 a roll, and then this TPU, we've kind of found it for $30, $40 a roll, so it's a lot more affordable. So TPU with the horizontal layer lines absolutely will not work because it's too weak, but TPU in the other way would. You know, this thing took lots and lots of abuse. So under the skids, I have no doubts that it'll perform quite well. So that's kind of the recap. Any questions or comments, let me know. Thanks for watching, and that's how I've come to the conclusion of what skids to post on lgworks.ca. Thanks.